Alrighty, so I forgot to hit record whenever I did my webinar earlier today, so you are all getting a brand new, fresh sheet metal introduction. So those of you that were having issues with the audio, I apologize. Hopefully this works a little better for you. So let's jump right into Inventor sheet metal. So the first thing is Inventor sheet metal is a separate file type. So you can convert a regular part file into a sheet metal file if you want to, but if you know you're going to be making sheet metal, just start it with sheet metal in the first place. So we're going to pick a sheet metal millimeter IPT. This applies to millimeter English, doesn't matter what the format is. So it is a separate environment inside of Inventor. So there is a sheet metal tab. There are sheet metal specific tools inside of Inventor. So face, flange, contour flange, rip, corner rounds, corner chamfer. There's a whole list of commands. But then you still have access to everything else. I will caution you, though, when you're creating sheet metal components, for instance, if you create a coil or some kind of crazy emboss or a sweep or a revolve, it may not flatten if you're kind of using these default 3D modeling tools. So as much as possible, you want to make sure that you stay inside that sheet metal environment. If you do have to create some really custom pieces, you can do that, but just be aware that you may not be able to flatten that component or see that feature or whatever it might be in the flat pattern. But the thing about sheet metal that's a little bit different than a part file is it has a style. So if you go to sheet metal defaults, we have a sheet metal rule that it follows, and there are rules for the unfolding that occurs inside of sheet metal. There's rules for the material that it's using. There's rules for the thickness. So we're going to start with the basic sheet metal rule. So I'm going to hit this edit button, and don't be intimidated by the dialog box. It's a pretty straightforward dialog box. And what's happening here is Inventor is controlling everything that you're creating inside of sheet metal, right? So the first thing you want to create is the sheet. So what's the material? If you want it to be made out of stainless steel or aluminum or whatever you happen to be doing, you can put that in there. It doesn't just have to be generic material. That way you get accurate weights and center of gravity. So I'd highly recommend that when you're doing sheet metal, just like any other part inside of Inventor, that you actually apply the appropriate material. So we're just going to do a steel mild. That way we can get some accurate weights and center of gravities. Also, material thickness. This drives everything in Inventor. And if your material is a millimeter, make it a millimeter. If it's half a millimeter, make it half a millimeter. So I'm just going to do 1 millimeter. And then this is where it starts to get a little more complicated. And if you have a sheet metal fabricator on site. So if you have someone down on your shop floor and they're bending sheet metal for you, they probably know a lot of this information and could help you fill this in. If you outsource some of this sheet metal, you might have to send an email or two or ask a few questions, but all of this information is based off of default sheet metal manufacturing styles. So for instance, whenever there is a miter, rip, or seam gap, so when there's a gap between the material, how big is that gap? And by default, it's the thickness of the material. You could make it smaller. There needs to be some type of gap because obviously if they touch, then it's not sheet metal because the components are touching. Keep in mind, Inventor doesn't take into account like over folding components, so they are touching. So there's some modeling techniques you might need to do that. So that's the sheet. There's also unfolding rules. So the way you unfold things is it's based off of a linear by default, and it's a K factor. So that is a percentage or a unit. So you see it's UL, it's unitless. This isn't like an inch or a millimeter. It's basically a value that it's going to stretch that material across that bend. In most cases, you're going to have a bend table. So based off of the thickness and based off of how that angle is on that bend. So usually your sheet metal fabricators are going to have a bend table that's going to dictate that information. So you can actually build a bend table right inside of Inventor. You can also base this off of some kind of custom equation. So you can see, you can build that as much as you want. We're going to stick with K factor. This tends to be the default just when folks are creating sheet metal inside of Inventor. But fabrication-wise, it's going to be a bend table. I just don't have access to really good bend table information, so that's why we're just going to use the K factor. So I will go back to, so that's the unfolding. I'm going to go back to the sheet metal rules. It's going to ask, do I want to save it? I'm going to hit yes. So that's the sheet. The bend, so when you're creating a bend, how does it treat that bend, and what's the relief that's going to occur if that material isn't like the full length of a bend? And you'll see what I mean whenever we start creating stuff. So we have a straight bend, a round bend. You can see that preview automatically updating. You can see the A, B, and C values updating. If we do a tear, it's only a C value. That's the remnant that is left over. So as you're building this, this is why it's super important to know how your sheet metal is actually being cut and folded, because you could make a part inside of Inventor with sheet metal, and when you actually give it to them, it might not work and fit the default end folded product that you want it to be, because you have different relief shapes, you have different bend parameters, you're not following their bend table. So like I said, this is why you want to make sure you talk to the folks that are actually doing the fabrication of your sheet metal. Corners, same thing. There's all types of options for whenever two corners come together. Intersections. Whenever two intersections come together, or whenever three intersections come together. And as you pick through these, you'll see what the difference is. So you can have a tear, you can have an arc weld. So this is going to be a bend that whenever they come together, that piece gets arc welded. You can have a regular linear weld. So all kinds of options. We're going to go to kind of that default trim to bend. And basically what that does is it goes to the edges of the bend and cuts that out. That tends to be one of the defaults that a lot of folks use. And then three bend intersections. You have a few less options, but there is a no replacement. So that basically does to the corners of the bend. You can go full round. You can come in here and add a radius. So all kinds of options. An intersection goes to a point. All types of things that you can change here. Once you have these set, you can have multiple default sheet metal styles inside of Inventor. So we're just going to save this one. If you wanted to create a brand new one for a different material thickness, so keep in mind, material thickness changes a lot whenever you're creating sheet metal. So if you're going from 1 millimeter to 3 to 5 to 10, whatever it is, not that you'd have really 10 millimeter thick sheet metal, that's kind of thick, but you get the idea. So you want to make sure that you create the styles that are going to follow the sheet metal that you're doing. And sorry for being 8 minutes in and we're just staring at dialog boxes. So let's close this and let's close that. So now let's actually start to make some stuff. So inside of the sheet metal environment, it works just like a regular part file. So we're going to create some sketches. I'm going to start out with basically just a rectangle, and I'm going to put a new sketch on this plane, and I didn't mean to change the name of my origin plane, so let's do a new sketch right there. I'm going to add a 2-point rectangle. Let's dimension this, and let's make this 50 millimeters by 50 millimeters. And I'm going to center this. And the reason you do this, it's just a best practice. And we've talked about this before in other sessions we've done. You want to build things on 0, 0, 0 if you can. That way, if you want to do some mirroring or some patterning and you want it to be revolving around the origin point, it's just a good practice to build things on 0, 0. I'm going to finish my sketch, and I'm going to create a face. Face is going to automatically apply that material thickness. So that 1 millimeter thickness that I talked about earlier, that's what's here. That there isn't a distance command in here like you would with the extrude. I could not have it follow some of the rules, but that kind of defeats the purpose of setting up a rule. You do need to be very aware of what side sheet metal offsets to. So by default, this came up. I could push it down. And this is super critical, not just for the face command, but for a lot of the commands inside of sheet metal. The sheet metal could actually add material if it adds it to the outside. So this is 50 millimeters by 50 millimeters. And you'll see in a second, whenever I do some flanges, how it could make this, 51 millimeters or 52 millimeters or whatever that distance is whenever it starts to add to the outside. So be aware of the offsets. So that's the face command, and you can create faces all day long. It's just a regular extrude command, but with a specific sheet metal thickness. So what I'm going to do now is I'm going to switch over to the flange command, and it does exactly that. And that's why it didn't work before, because there wasn't any geometry. I need geometry to create the flanges. So what the flange is going to allow me to do is pick an edge, and this is where the edge you pick is important. If I pick the bottom edge, it thinks I want to go down. I can delete that, and I can pick the top edge, and it thinks I want to go up. So depending on what edge you select, you're going to get different results. So let me start that one again. So if I pick the top edge, and this is what I was talking about earlier. So if I go to a side view of this, you can see that it is still 50 millimeters because it kept it inside of the extents. If I switch this to bend from adjacent face, it's going to add the entire thickness of the radius plus that material thickness. So now if I apply this, and I go to do my measure command now. So if I measure this, and I go from this outside face here to this face here, if I wanted to keep this at 50 millimeters, I'm now at 52 millimeters. And if I continue to do this as I'm creating my component, you could be halfway through creating your sheet metal file, and next thing you know, this thing is 56 millimeters when it was only supposed to be 50, depending on how those offsets get pushed when you're creating these features. So be really aware of what's going on and the direction when you're creating this. So I'm going to go back to here. I'm going to move this to the inside. The good thing is you can easily change it. You can actually come in here and change the distance of that flange. Let's say we want that to be 12 millimeters. And also, if I don't want that flange to be the entire length, and it's not here by default, but if I pick on these additional options here, these little double arrows, so the extent of this, it follows the entire edge. If I go to width, it centers it, and it only makes it 10 millimeters. So if I change that to 25 millimeters, you can see what it gives me. I can change that to offset, and it's going to do different offset. I can do from to, so if I want this to go to and from different faces, just like a regular extrude command. But I like the width option because it's going to automatically center it. I could do an offset and have it go from one side, but that's not what I want it to do, so I'm going to do an offset there. I can see that it's going to stay inside of my, my body there. And I'm going to hit OK. And you can see it follows all the sheet metal styles that I defined. So it puts in that relief shape. It adds all that information. And the cool thing is when I start to create, let me change the color of this to something a little bit better. I like the yellow. I think the lines show up a little bit better. What I can do now is I can generate a flat pattern. So inside of my sheet metal, I'm going to save this, and let's go to 33s. I want to create a flat pattern because that's ultimately what you're doing this for, because if you didn't care about flat patterns, right, you would just model this as a regular part. But what we do is we create flat pattern. It automatically flattens our object. It puts our bend lines in, the center of the bends, the reliefs, everything it needs to. Inside of this part file, I now have a separate area specifically for my flat pattern. So I can go back to the 3D model and back to the flat pattern. These are associative, so be aware of that. So now, if I start to add some additional flanges, so let's say I want to take this flange here, and this is where building stuff on 0, 0, 0 is really important. I could come in here and add 4 different flanges if this is what I wanted to do. But remember, I built this exactly on 0, 0. So I can do a circular pattern, pick that flange. I can pick my center axis right there. I'm going to do 4 of these. It's going to automatically pick that up. Now, this wouldn't work if I did like 3 or 5, obviously, because this is sheet metal. But it's going to automatically pick that information up. It's going to automatically update my sheet metal pattern. And I couldn't have done this easily if I wouldn't have built this on 0, 0. So this is some of that benefit of building geometry on 0, 0, 0. So now what I want to do is I want to add in some additional features. So a command that is really powerful. You could do this with a contour, which we'll talk about in a second, or I could add a couple of small flanges. But the hem command, and what the hem command allows me to do is it allows me to add a rigidity hem to a particular edge. So whenever I pick the outside edge, it assumes that hem wants to go to the outside. You can see that dynamic preview. I can add in different types of hem, so I can do a teardrop hem, I can do a rolled hem, I can do a double hem if I want to add some real rigidity and strength to this. I'm just going to do a single hem. And I can also pick edges in sequence. So I'm just going to apply this. I'm going to add another one, and depending on what edge you pick, if I pick the inside face, let's say these ones here, I want to go to the inside face. If I pick the inside face, it goes to the inside. If I pick the outside face, it goes to the outside. And again, this is where creating that geometry and being aware of which way the offsets are going. So right now, this is over, 50 millimeters. So it's the thickness of this material plus this gap. So now I'm probably like, 50, I'm probably 53 millimeters at this point. So you got to be aware of when you're creating this geometry, how that is going to affect your end result. And if I flat pattern it, I see all of my center lines for my bends and my bend extents. So that is the contour, the hem command. But I do want to talk about the contour flange. So I'm going to save this file because we're going to come back to it. And another way to create sheet metal is if I want to create a pretty complicated profile all at one time. So rather than doing flange, 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 or if I have a curved component, maybe something that is rounded or rolled, rather than doing faces and flanges, I'm just going to do a new sketch on this face. And I'm going to just start to draw. And let's say this is going to be 15. Let's try that again. Line command. So this is going to be 15 millimeters. Maybe this is going to be 36 millimeters. I'm going to add a radius to this. Maybe we'll come to here and there. So let's say this is some sheet metal bizarre piece that we're making. So rather than doing a face, a flange, a flange, a flange, trying to get that, I can just draw the profile of this, do a contour flange, and it picks up all of that information at one time. Now you want to be aware there's 2 different types of offsets in here. So the first one is which way the material gets offset. So that's this offset. So I can go to the one side, the outside. I can split the difference so it actually goes right down the middle. That's probably not what you want to do, but be aware this will affect the overall distance and basically the envelope of your sheet metal file if you have it go to one side versus the other. The other offset that you have access to, this is the offset where is it going to be right, left, so in or out. I could split the difference whichever way you want to do it, and how long you want this to be. So let's make that 35 millimeters. And now I have this kind of sheet metal, maybe this is like a clip that is used to create a piece of geometry here. So if you notice, I have rounded edges here where I drew it as square. And again, because this is sheet metal, Inventor is following the sheet metal standard that I defined, or that's defined inside of this file. So that's why you don't have square corners, because it's sheet metal. We bend this stuff. So there's going to be some type of rounded corner on it. A couple interesting things that you can do is you can mix and match all these features. So I did a face and a flange before. This time I did a face and a face. Oh, I'm sorry, I did a contour flange rather. But I can now come in here and I can start to add in flanges. So if I want to add in a flange here and here, I can start to mix and match those flanges and contour flanges and faces and hems and do all kinds of really interesting, complex sheet metal components. And remember, all you have to do is hit flat pattern, and now you have that flat pattern for that particular component. That center line, by the way, is the center line of that rounded pattern. Okay? So contour flange, flange, face, and hem. So those are the only ones I'm going to cover inside of the Create. We're going to do another webinar next Thursday where we're going to cover the rest of these, I'll say more advanced sheet metal features, but doing lofted, contour rolls, bending, folding, that sort of stuff. But there's a handful of additional sheet metal tools that I want to make sure that you're aware of. So let's go back over to this component here. And that is, when you're creating geometry, you could use, regular extrusions and that sort of thing, but you'll want to make sure that you use in sheet metal the cut command. And the reason you do that is it takes into account the thickness of the material. So if the material thickness changes, and there's also some really cool features that you can actually do and add inside of the sheet metal environment. So what I'm going to do is I'm going to go to this circular pattern. First I'm going to kill this hem. I don't want that hem. And what I want to do is, let's say that I need to put an extrusion that wraps around this face. Not a super easy thing to do, even if you were doing this in a regular part file, but by using sheet metal features, I'm going to do a sketch right here. And here's a really neat thing that you have inside of Inventor Sheet Metal is you have project flat pattern. This is so cool because what I can do is I can project flat pattern of this face right here, and it's going to take that face and project it in my current sketch. So let's say I have some venting that needs to start on this side, go across the bend, and be maybe 10 millimeters from that edge. I can actually just create my 2-point rectangle, and I'm just going to do one of these because we're going to do a pattern command. I'm going to dimension from one edge to another. So this is going to be 1.5 millimeters, and there we go. Let's move that up. Let's dimension from here to here. That's going to be 1 millimeter, and we're going to say this is going to be a millimeter from this edge. And now this is the cool part. So from that edge where it starts to round over, I'm going to be 10 millimeters. So remember, this is going across that bend where that projected geometry came from. And you only get that project flat pattern inside of sheet metal. So if you haven't seen it before, you just haven't been inside the sheet metal environment. I'm going to finish my sketch. And this is something you can't do with the extrude command. This is why the cut command is so cool inside of sheet metal. So I'll do a cut. I'm going to cut across the bend. You can see the preview of what it's doing. I'm going to hit OK. And now I have this really cool vent that is going across that particular edge, exactly 10 millimeters from that edge. And I'm going to change that sketch a little bit because I want that to be a little bit bigger. Make that 2 millimeters, and let's make this 1 millimeter. There we go. Now, just like we would in a part file, if I want to do a linear pattern of this, I can just do a rectangular pattern, grab that, choose my direction, flip it the other way. I want 5 of these, and I want them to be 1 millimeter. Let's make that 2 millimeters apart. And now I have this really complex venting pattern in my 2D. I'm going to save this. And I'll just go to my flat pattern. And it's automatically there for me. So some really great commands like cut inside of the sheet metal pattern ensure that you're doing things the way you'd probably be creating them in reality. Because you probably would do these as potentially as a punch or a cut in the flat pattern and then fold. And that's the other thing too. It's a little difficult sometimes to think of because obviously the way you create sheet metal is you start with a flat pattern and then you fold it. In Inventor, we draw the end result and then we generate the flat pattern. So just kind of keep that in mind. And this is where, again, working with those folks that are creating this, the folks doing the fabrication, knowing how they build the sheet metal can really help you create really great, accurate sheet metal parts. Because I've seen situations where people make these beautiful sheet metal parts, they send it to the shop, it doesn't work, the shop just folds it and makes it work anyways, and they spend a lot of extra time. So make sure you're working with the folks that are fabricating for you. So back to this folded model. We want to make sure also that when we're doing things like hole commands, that just like we did in a regular part file, don't draw a circle and extrude it. Actually issue the hole command. So let's say we have a couple of ports that are going to be punching through here. I'm just going to do actually, let's just do a hole command. And we'll just do a linear placement. So I'll put a hole there. From this edge, we're going to be 5 millimeters. From this edge, we're going to be 5 millimeters, and 3 millimeters is a good distance for me, or diameter for me. We're going to hit apply. And again, it automatically puts in the thickness of the material, so I don't have to tell it. I don't know if you noticed, there isn't a depth command here. So I don't typically in the hole command where you would do the hole command. Let's actually go over to a 3D model and I issue this hole command. Oh, it knows. I thought that may have snuck in there. No, so it does that. Yeah, so sheet metal, there is no depth option. I take that back. I'm looking in the wrong spot. So distance. Wow, that was really dumb of me. So I could come in here and put in a specific distance. I could say through all. I could actually put in thickness is the default. Whenever I do distance, it's actually thickness. So if I didn't want to do through all, that if you had something folding in and underneath this, you wouldn't want that hole to punch all the way through. So doing distance and thickness is probably a good way of doing that. But the fact that I built this on 0, 0, I can now come in here and I can, again, do that circular pattern if I wanted to. Pick the hole, pick the axis. I want to do 4 of these, get them in the corners. And there is my flat pattern, totally updated with everything that I need. Okay, so the very last thing I want to talk about is the corner round and corner chamfer command. So this isn't your typical chamfer and round, because typically whenever you're in sheet metal, you're not going to round these edges. You may grind them as like a fabrication spec later on to like deburr the edges or something like that. But when I issue the corner round or corner chamfer, I can't even pick these edges because sheet metal knows that I can only pick edges that are basically perpendicular to the thickness of the material. So whenever I want to come in here and let's say this side gets radiuses, I can come in here and I can add 2 different radiuses. Let's say these are going to be 2 millimeters each. Hit OK. And then I can come over here and I can do a corner. I did that one. Let's do corner chamfer. Works the exact same way. I can do a corner chamfer. We'll make that 2 millimeters as well. We'll hit apply and cancel. And now you can start to see your sheet metal component really start to take shape. So again, you could have used the regular chamfer command, but guess what? The regular chamfer command is going to let you chamfer anything. I can chamfer in this direction. I can chamfer, in the other direction. So really, probably not something you would do inside of sheet metal. So make sure you stick with the corner round and corner chamfer commands inside of the sheet metal environment. So real quick, I want to show you how to make drawings of this because it is a little bit different. So let's save this. And let's do a new ANSI millimeter drawing. And let's change this sheet size. Let's go down to a B size. And let's get rid of that. And let's get a smaller title block. There we go. So let's do a base view. And by default, the base view is going to be the folded model. And if you haven't done sheet metal before, you probably haven't seen this because this only shows up when it knows it's a sheet metal file. But if you want to grab the flat pattern, you switch over to flat pattern. We can adjust the scale. Let's make that 2. Hit OK. So there is our flat pattern for this component. I'm going to do another base view. I'm going to this time do the folded model. And let's pick a different view here. Let's do the, yeah, that view's actually okay. Let's pull this over, bring our other views in. And let's edit this view here. That size is a little big. Let's do 1.5. Remember, this is scaled, so if you printed this, it would be 1.5 times. Now let's go to our, we're going to do a projected view. We're going to do an isometric view. Let's edit this view, and let's turn this to a shaded view. So a really easy way to create 2D drawings, and I always like doing drawings with shaded views on. I think they look really good. And then remember, because this is all done the right way, you can see that all of my measurements are going to be there for my flat pattern. They're going to be there for my folded model. So whatever you happen to be doing inside of Inventor with sheet metal, the sheet metal environment really has a lot of different pieces of functionality and features that allow you to create super fast, super easy pieces of sheet metal. So what we're going to do next week is we are going to dig into the remaining creation tools, so lofted flanges, contour flanges. We'll talk about some of the corner seams. We'll talk about creating punches and doing rips. We'll talk about how we can create flat components and then fold them. There's an option in there to do that, but make sure you check us out next week for another Inventor webinar. And again, it's going to be sheet metal, I'll say 2.0. So everybody have a good week, and I'll see you later.